Okay, the next presenter is Densec, which is Michael Kozicki. Oh,
We're Densec ID, we make fingerprints for things. So what if you could just look at something, look at an item, and get information immediately on not only what, but who it is, where it came from, if it's genuine, and what to do with it. This superpower would revolutionize manufacturing, maintenance, and recycling. Now, Industry 4.0, which is this new industrial revolution, has things pretty much tied up with in the back end with blockchain and DLTs in the database side. But what's missing is a digital trigger, a physical identifier that really meets all the requirements of this new industrial revolution, which include low cost, individualization, machine readable, something that can be put directly on items of various materials and different types, scalable in size, so it can be put on any size of item, durable to withstand the life cycle of the items, and secure. We think we've got that. We think we have it in something we call the Dendritic Identifier. It can be applied with a simple stamping process using inexpensive materials. We get a unique pattern every time. It can't easily be cloned, copied, or removed without it being obvious. It's read using our proprietary app, which converts the geometry of this pattern into a unique identifier, and it survives from cradle to grave. They're like fingerprints for things, quite literally. They have the same kind of shape, in essence, as fingerprints. They have the same kind of attributes as fingerprints. So benefits to manufacturing and supply chains are many. I mean, much higher efficiency, more transparency, better quality control, increased personalization, because they're like snowflakes, they're different every time, reduced fraud because they are secure, and less waste. I mean, all of these are the holy grails of Industry 4.0. So we've developed and protected the smart inks that are involved in these materials and these patterns, the formation methods and the reading software. We see revenue generation being in those areas in the application techniques and the materials, and ultimately in the reading software. We've got some great IP protection. We've got 9 issued US patents and 7 EU equivalents. We've had about $500,000 in research funding from the US government. And we've already got prototypes and proof of concepts in the hands of various industry partners. And if you look at the timeline, we really only started this a year ago. We already have a JDA with a Tier 1 product ID company. We're working with Toyota in asset tracking in one of their facilities, and we plan on having our first real customer, paying customer, and DoD engagement by the end of this year. In fact, we're in front of the Navy next week, which could be rather interesting. As far as the core team is concerned, there's myself and Alex Uti, who take clearly the technical and the business side respectively. And as far as the market is concerned, we're selling into a gigantic market, multi-billion-dollar label and, multi-million-dollar label and reader market, and of course anti-counterfeiting markets. But we're seeing a lot through our customer discovery, a lot of manufacturers that are craving just this kind of thing. We're at 80K into a 2 million raise, and we're driving towards COI 2024 with our customers. And that's it. We're Densec ID, and we welcome your questions. Thank you very much.
Thank you. Questions? Yes.
Help me understand a little bit more on how this is cannot be copied.
Right.
Why is it that somebody cannot see the dendritic imprint, take a picture of it, form it, and start, stamping it?
It's, the perfect question. What we couldn't show in the 3-minute compression, which is, typical of these talks, you leave out all the good stuff, sorry. But what we do is we use materials that are common in the paint and coatings industries, as it turns out, to make these things. There's a lot of different polymers, like acrylics, and we've got some fancy stuff that we use in the semiconductor applications. We'll come back to in a second. But what we also do is we create a unique optical signature in these things by adding in small microscale flakes of mica. into these. These are the same materials that you find in metal flake paints, you know, the nice fancy metal paints you get in your cars. We use small quantities of these same materials, and those give you this wonderful constellation effect where you, just taking a cell phone, you tilt it, and you can see different constellations appearing, which are very, very difficult to fake, very difficult to replicate. And that's how we get around the kind of higher security levels. There is a subtle third dimension on these patterns, I should note. They're not absolutely flat. They're about 10 microns high, or thereabouts, regardless of how wide they are. But that allows us to get that kind of three-dimensionality, almost holographic in some respects.
So you imprint the dendritic label, so to speak, on the product.
Yes.
And then you put it on a library somewhere, and you say that
Yes,
this specific imprint with those mica compositions
Yep.
belongs to this semiconductor product?
That's exactly right. So depending on the product, what we're doing, and actually in all cases, is we capture the geometric image, which gives us our unique ID. One of the fascinating things about dendrites, I mean, nature loves dendrites. You look out the window there, there's a ton of them out there in the form of trees. You see them in riverbeds, you see them in lightning, you see them in our bodies. Nature loves them because they're very easy to form, but they also have some really interesting attributes, including what they call a high information entropy coupled with a low structural entropy, which is a really fancy way of saying they're different every time, but they're also predictable. They have this predictable structure, you know, that you can use to essentially fill in the gaps if there's a problem, just like fingerprints. So that's one of the really important things about these dendrites. So we scan the shape in, convert that using our algorithms to a unique identifier, which of course then gets used to essentially connect your product in the real world to its digital presence in the whatever database you're using. At the same time, of course, you do have essentially like a 3D image of those constellations that you can, if you do so choose, use for authentication. So there are two separate functions, identification, authentication.
And each customer does that, or do you provide
No,
a central database?
we do this. Yeah, we do that part. The customer keeps their own database. The customer keeps their own information. On the back end, it's all their stuff. What we do is we provide the identifiers, we provide the reader, we provide the conversion software, and we can provide that link, that hash, that basically allows the customer to point their database back to that individual unique item, if that makes sense. So it's quite like a fingerprint in that respect.
So how do you actually get these printed onto items? Do you have your own printers?
It's the most ridiculously simple process on the planet, which is patented, by the way, so just back off, okay? Literally, it's a printing process. It's like a stamping process. You take a droplet of the material you're using, say if you're using acrylic or epoxy or some of these, as I say, fancier cyclized polyolefin materials with the reflectors in it. You stamp it onto your surface, you release it, and nature says, there you go, there's a dendrite. If you don't believe me, take some dish soap and try squishing it, under, like a plastic sheet and lift it up quickly, and you'll form a dendrite. It's as simple as that. Of course, the choice of materials depends on the use environment. For example, we've got a lot going on, I'm pleased to say. In fact, we're quite literally overwhelmed, which is why we're looking for a little more investment to hire more people. Alex and I are slightly, slightly overwhelmed by the interest. Depending on the application, for example, for the semiconductor side of things, we're working with a very large manufacturer of semiconductors in the US. They, of course, require high purity, and they also require high temperature because they reflow their products at 250 degrees C. So that's why we have to. So we partner with a large chemical company. They're supplying cyclized polyolefins, and we're using those. You look at the other partnerships we have are in industrial equipment. They want stuff that will withstand abrasion and sort of nasty stuff going on. And so we're using epoxies with essentially with a kind of steel reinforcement in them, which are very, very tough. And so the choice of material really depends on what the application is. But you'd be astonished at how many different things form beautiful dendrites. And as I say, the secret of the dendrites are they're different every time, but they have that predictability, so you've got kind of like built-in error correction, if you like, in there.
Are they, by definition, visible with the human eye, or can you do an invisible?
We can do them invisible, it turns out. We've had a lot of requests for very, very small dendrites, and of course in the semiconductor industry, when they're putting it on packages, we're talking about stuff that is, sub-millimeter, so you can't really tell what's going on without a microscope. Of course, we can play all sorts of tricks, like putting them underneath layers and then reading them with infrared and reading them with polarized light. And, we started off, interestingly enough, the USDA were very generous with their funding, and they wanted them readable by cell phone. So they wanted them very obvious, on packages, so you could track, those individual packages all the way back to where they came, where the produce came from in the field and the likes. But we can do all sorts of kind of like more clandestine stuff. And we're excited about looking at all these different possibilities.
Tulsi?
Can you help me think through the best use cases for this versus like a barcode or
Yes.
RFID? Is it high margin products? Is it things that like metal, semiconductors?
Absolutely. Wonderful question, of course, because this is one of the things we struggled with. We initially thought there's a really obvious market here for protecting high-end goods, Gucci handbags or whatever, kind of stuff. And it turns out there's two very, very obvious markets. One is markets in which don't have good identifiers, good, unique, individualized, secure identifiers. And interestingly enough, that's the semiconductor market. The semiconductor market is, particularly with heterogeneous integration, has opened up their supply chain to the world. It's not just Intel or not just Samsung that's making chips anymore that go into their packages. There's stuff coming from all over the place. So they're very, very interested in a unique identifier that fits with the semiconductor industry, which doesn't exist, believe it or not. And then, of course, you've got the companies that are just fed up using, labels with barcodes that fall off after a while, and so you can no longer maintain the part because you don't know what the heck it is, or, it's just that people want a nice consolidation of a high-performance but low-cost tagging technology, really, is what it comes down to. Ultimately, once we get going in these markets that demand our kind of technology, it's going to be a lot easier to start displacing, barcodes and QR codes and, if you like, the less demanding markets.
Very quickly, what's your business model? And what are you actually selling?
So it would be licensing and selling the actual printing, if you like, quote-unquote printing capability. We are in bed with a tier one product ID company, and we would be essentially licensing the technology to them to allow them to do, for example, labels. But we can also do the equipment, the actual stamping equipment. We'll sell the smart inks. You've got to put smart in front of things to make them sound better. So we've got these smart inks, which are really just mixtures of off-the-shelf materials that we can sell into the market. And of course, we license the software because you cannot read these things. You cannot, interpret them without our software. So we'll license the software on a per-use basis kind of thing.
Great. Thank you very much, Michael.
Thank you.
I want to give him a hand.
Thank you very much, folks. Thank you.